Let's talk about atoms. What do they look like? Strictly speaking, we still don't know. In fact, there's a high chance we'll never know. Atoms are far too small for any equipment to be able to observe, which is why all we can do is make experiments and make theories out of them. Let's check how far we've come. The first idea of atoms came a long time ago in ancient Greece. Several philosophers, such as Thales or Empedocles, were coming up with different theories as to how the world was made. The prevailing theory being the four-element theory by Aristotle. One of these philosophers, Democritus, is the first man to think of the atom. His theory was that the world was made of many different particles, which were indestructible and indivisible. Thus, the atomic theory was made. The theory was passed on down to the physicist John Dalton. He thought up the first model for what atoms look like, a simple ball. This is why it was named the billiard ball model. He came up with the first basic rules about atoms in 1808 in his book New System of Chemical Philosophy. It's made of four basic rules we call Dalton's atomic theory. 1. The world is made of indestructible and indivisible pieces called atoms. 2. The same atoms have the same size, mass, and characteristics. 3. In a chemical change, atoms only rearrange. They do not change into different atoms, create atoms, or destroy atoms. 4. Chemical compounds are made in simple whole number ratios of atoms of each element. Today, almost all of these rules have been proven false. The first rule was proven wrong when protons, neutrons, and electrons were discovered. The second one was broken when isotopes were discovered. The third one was broken when nuclear reactions managed to create elements. The fourth was broken by another French chemist, Joseph-Louis Gay-Lussac's experiment with water and hydrogen chloride, but an Italian chemist, Amedeo Avogadro, improved the fourth law to fit the experiment. The next physicist who challenged Dalton's theory was J. Thompson. During an experiment with a cathode ray tube sometime between 1898 and 1903, he found out that the cathode ray held negative particles with a high charge-to-mass ratio. Through this, he discovered the existence of electrons, negatively charged particles, which formed atoms. At this point, Thompson changed the shape of the atom from marbles to electron pudding, thus making the plum pudding model. Ernest Rutherford made the third atomic model in 1911. In the 19th century, scientists were starting to learn that certain elements, such as uranium, gave out radiation. The radiation was mainly formed of alpha particles, beta particles, and gamma radiation. Out of these, Rutherford took the alpha particles and shot a ray through a very thin sheet of gold foil. If atoms were only made up of electrons, which are negative, the particles, which are positive, should have went in a straight line. Instead, some of them spread out. This was the discovery of positive particles in the atom, which brought the idea of the nucleus in an atom. Hence, the planetary model of the atom was made, where there was a positive nucleus and negative electrons going around the nucleus like an orbit. The problem came with the planetary model said that hydrogen can only be stable for 16 picoseconds, because the electromagnetic waves emitted from the atom as it travels will cause the charged particles to lose energy and collapse into the nucleus. This was contradictory to the fact that hydrogen is always stable 24/7. So the next scientist to challenge the atoms came up, and that was the Danish physicist, Niels Bohr. Calculating energy spectra in different atoms, he evaluated the electromagnetic radiation emitted to come to the conclusion that electrons existed in different quantized orbits, namely energy levels. This theory stated that electromagnetic radiation was only emitted during electron transfer between different energy levels, thus did not affect the orbit of the electrons. This became the Rutherford-Bohr model. Another major flaw with the Rutherford model was the fact that protons always tend to push each other away, yet an atom manages to remain inside the nucleus tightly so that electrons can orbit. At the time Rutherford made his model, a theory was made that the protons were held together by nuclear electrons within the nucleus, separate from the external electrons orbiting the atom. Eventually, after the Bohr model was made, scientists realized that with the velocity the electron travels in, there's no way that it would remain intact within the nucleus. Studying atomic behavior, scientists concluded that a neutral particle must exist to provide enough energy to keep the protons together. Even so, no scientist was able to discover this neutron until James Chadwick analyzed the radiation of alpha decay for beryllium in 1932. The fifth and currently used atom model is in the electron cloud, also known as the orbital. German physicist Werner Heisenberg came up with the uncertainty principle, a law which stated that you can never locate and calculate the momentum of an electron at the same time, because the electron is far too fast. By the time one value is calculated, the other already changed. Austrian professor Erwin Schrödinger created the wave function to locate the approximate probability of where the electron would be. This, when graphed on a 3D platform, shows the shape of a sphere, giving it the name of orbitals. This is, as far as we can tell, what an atom looks like.